All right, this is your first out of Trig lesson. We'll still be using Trig for the rest of the year, but we're done with learning about Trig, okay? So this one is going to be more like your Algebra 2. We're going to be doing substitution for solving the system of equations. Start by thinking about this problem. On a farm with only cows and chickens, you are told that there are 27 heads and 66 legs. How many of each animal are there? I'm going to leave you with that for a second. We'll come back to this question at the end, and I want to let it marinate in your brain. Okay. All right. Today's lesson, solving systems of equations by substitution. In this lesson, you will solve systems of equations by substitution. Use systems of equations to model and solve real-life problems, kind of like that cows and chickens problem. Okay, let's start with one to kind of freshen your memory here. We have a system of equations. A system means more than one equation, so we have two equations. And how math works, or how algebra works anyway, you need one equation for every unknown that you have. And right now we have two things we don't know, an x and then a y. That means we need two equations. And if you had three unknowns, x, y, and z, you would need three equations to complete the problem. So let's see. Since we're doing it by substitution, we're going to look for a substitute. And you've heard that word in school quite a bit. A substitute means to find something that can be used for something else. Okay. Since we have x here, we have something solved for x. Let's say this is the teacher, and the substitute would be y plus 4. So now we have a substitute for my x. Now we're going to take that substitute and we're going to use it in the other equation. So I'm going to put that y plus 4 into the other equation, because x is going to be gone, just like when your teacher's gone, the substitute takes its place. So the x, which is the teacher, leaves, and so the substitute comes in and goes in its place. So we're going to do that right now. I'm going to take my substitute and put it in for x. And when we do that, always remember to put parentheses around it, because once you start solving, you're going to lose negative signs. There's no negative signs in this particular problem, but it's a really good habit to put your substitute in parentheses. Now all we do is some basic algebra from here on. Okay, on some of the problems, algebra will get a little bit harder, but basically we've done the substitution part at the very beginning. We're done with the substitution part, and now we're going to just do some algebra. So just combining my like terms, I get 2y plus 4 is equal to 4. Subtracting 4 from both sides, I get 2y is equal to 0. Divide both sides by 2, I get y is equal to 0. Okay, just to help you understand what's going on here, when we say solve a system of equations, we're looking for where these two graphs, these two happen to be lines, where do they cross on when you graph them? They cross at a point. So I don't have a point yet. Y is equal to 0. So now I want to find out a point. So I need x. So I'm always going to take the one I found, put it back in the substitute right here, 0 plus 4, and I get x is equal to 4. Now I write my answer as a point where the two graphs cross. How's that? Okay, you did a lot of these in algebra. Even in Algebra 1 we did this. In Algebra 2 you did some more. Okay, make sure you always check your work. If you put this 4 and the 0 back in either one of these, or both of them, you should come out with something that's always true. 4 plus 0 is 4, and 4 is equal to 0 plus 4, right? Here's your 4, here's your 0, that's true. 4, 0, that's also true. All right. Okay, now let's talk about problems that you may not remember that well. Before the last problem, we're talking about two straight lines. Now we have a conic. A conic is just either an ellipse, a circle, a hyperbola. Okay, those are conics. And a straight line So how many solutions are there for a conic and a straight line? So I'm asking you, how many ways can you make a line and a conic, in this case an ellipse, intersect? So we're finding the number of places where they cross. How many ways can that happen? Well, as you see in this figure here, there is no solution. They don't touch each other. Another way we can think about it is if they touch each other at one point. That's just one solution. Are there any other ways that we can have a conic and a line interact with each other? Sure, there's this way where we have two solutions, right? Can we have more than two? We have no solutions, one solution, and two solutions. Can we have more than two? Not with a line and a conic, okay? What about with two conics? Let's say we have an ellipse and a circle. How many ways can we have those interact? Think about that for a second. Okay, you figure out all the ways that you can make them interact? Okay, let's say in this case there is no solution. Here's a parabola and an ellipse. There's one solution. Here's a parabola and another ellipse, two solutions. Are there? Can you make it three? Is there a way to make this three? Sure. Okay, kind of like the Toyota logo. And what about, is there a way to make four solutions? Yeah, if they cross like that, okay? You have four. Are there more than four solutions? Not with two conics. 4 is the maximum. You can have from 0 to 4. All right. So let's solve one of these. We have a linear. This is a linear because there's no squares. And since this is squared and this is squared, if you've forgotten, this is an ellipse. And we'll work on these later on. You can identify these. But we are either going to have 0, 1, or 2 solutions. And let's go ahead and solve this. So what do we do first? Well, I'm going to look for a substitute. And this is squared. I don't want to play around with that. And this has a 2 in front. Now here is something that I can isolate. So I can have this be what I'm substituting for. So I'm going to create a substitute. So I'm going to solve for x to create my substitute. Subtract the 2y from both sides. So now my substitute's 1 minus 2y. That's my substitute for x. And I'm going to put that up in the other equation. So now always use the parentheses, put 1 minus 2y in here. Otherwise, you're going to forget to FOIL it. And then plus 4y squared is equal to 25, like up here. When we FOIL that out, we get 1 minus 4y plus 4y squared. Okay? If you don't believe me, you can write it all out and distribute all the pieces. You should get this. Now we do all my algebra here, right? Combine my like terms. And I get 4y squared minus 8y squared minus 4y plus 1 is equal to 25. How do I solve a quadratic? Always make it equal to 0. Subtract the 25 from both sides. It looks like I can factor out a 4. So I'm going to factor out a 4 and divide both sides by 4. Divide that by 0, and that goes away. I'll get 2y squared minus y minus 6. And I'm going to try to factor it. If I can't, then I'm going to have to use the quadratic formula or complete the square. Hope this is factorable. And it is factorable. So it's 2y plus 3 times y minus 2. So using the zero product property, cutting this in half, solving this side for y, and then solving this one for y, I get negative 3 halves and positive 2. Alright, so now are we finished? No, we're not, because what am I looking for? I want to know where they intersect, and where they intersect are ordered pairs. I only have the y's. I now need to find the x's. Okay, so I'm going to put this back into my substitute here, okay? And I have a whole new page for that. All right, here. Oops, sorry. Okay, so substituting the values back in for y. I really should have substituted back into the substitute that I had over here. This PowerPoint is a little out of order, but that's all right. I'm going to substitute in here. It's all the same. Yeah, I'm just going to do a little more algebra here. So I'm going to cancel out the 2s and have -3 plus x is equal to 1. Add 3 to both sides. X is equal to 4. This 4 goes with this y. Okay. Now I plug in the 2 in for the y, and I get 2 times 2 plus x is equal to 1. Subtract the 4 from both sides. -3 goes with this y. So I need to write that as 2 ordered pairs, 4 comma -3 over 2, and -3 comma 2. All right. Okay. Now for some steps. Okay, Safe asked me to make steps. So here we go. Solving a system by substitution. First, find a substitute. You may be able to find it right in the problem already staring at you, or you may need to solve for one. You find the one that has the least stuff around it and get it by itself, and then on the other side you'll have the substitute for that variable. Put the substitute into the other equation. Take the substitute that you've created or found and put it in the other equation. Do some algebra magic and solve for the remaining variable, and then substitute into the substitute, okay, to find the other variable. So use the answers that you've gotten from step 3 and put them back into the substitute that you got from step 1 to find the other variable. Then write the answer as or an ordered pair or order pairs, depending on how many solutions there are. You can have up to 4 with 2 conics. With a line, 2 lines, you have 1 or none. With a line and a conic, you'll have 0, 1, or 2. Okay, and with 2 conics, you can have up to 4. Then the last step, check, because these problems are kind of long, and you'll hate to make a mistake somewhere in the algebra early on or near the end, and then stop and say, oh yeah, that's the answer. But just look back and make sure everything makes sense, that you didn't lose any negative signs. Use parentheses whenever you put in the substitute, okay, those kind of things. All right. Okay, so let's do another one. All right, here. You're going to get to do this one. See how far you can get. Pause to see how far you can get by yourself, and then come back and look at it. If you get a little stuck, there's a little trick with this one. So you get stuck, you can come back and look, but give it a try. All right, you either gave it a try or got flustered and couldn't find a substitute. Well, the trick here is that since we have a y squared here and a y squared here, that will actually be what I'm going to be looking for. Okay, so my substitute is going to be for y squared. It's going to be, I'll move the 16 to the other side, add 16, and I get 9x squared plus 16 is equal to y squared. Now I can take this and put it in there. I'm going to use the substitute for y squared and put that in there. See if that makes sense to you, right? Hope that makes sense to you. All right, then I always put them in parentheses. In this case, it didn't matter too much, but normally something is going to go wrong if you forget the parentheses. So now 14x squared plus 16 is equal to 30. Subtracting 16 from both sides and dividing both sides by 14. And taking the square root of both sides here, don't forget the plus and minus when you take the square root of a square. Because a positive 1 squared is 1 and a negative 1 squared is also 1. All right? Are we done? No, we need ordered pairs. So we're going to take the 1 and the negative 1. I'm going to put it right here into my substitute. All right, so when we do that, we're going to get, remember, taking the square root of both sides, right? So I'm going to get plus or minus. So now I'm going to put the plus or minus 1. Well, the plus or minus doesn't matter because we're going to square it. They both are going to come out positive. So it's going to be 1 times 9 plus 16, which is 25. Square root of 25 is 5. So I get a positive 5 and a negative 5. Now, how many answers do we have here? Well, we'll get to use the 1 with each one of the 5s, the positive 5 and the negative 5, and the negative 1 with each one of the 5s. So we're going to have actually 4 answers. We're going to have 4 places where these two conics cross each other. We've got 2 ellipses, and they can cross each other 4 times. If you think of 2 ellipses, you know, that are not going in the same direction, they can cross in 4 places, and these are the 4 places. 1, 5, negative 1, 5, and positive 1, negative 5, and negative, negative. Okay, so you can have all those combinations. Let's do a few more, and then we're done. Try and do this one. I'm trying to show you all the little tricks and sticky points in these problems. You should be able to work this one all the way through. This is kind of basic. Okay, I hope you gave it a good try. All right, so I see substitutes in here for the easiest thing for me to solve for is this x here. Okay, I don't want to solve that because I have to divide by 2. I'm going to end up with a half over here. I don't want that. And then the square root over here, no. This is going to give me a really complicated substitute, so I like this one. So I'm going to solve this one. So I subtract the 2y from both sides. Now my negative 2y is my substitute. Put that in for the x here. So put that in parentheses. So now I just FOIL this side out. Add the 2y to the other side, or actually subtract the 4 and then add the 2y to the other side. And then I'm going to factor this. So I'm going to factor out a y, use the zero product property, cut this where the multiplication is. So I've got y is equal to 0, and y minus 2 is equal to 0. So I get y is equal to 0. Put that 0 in here to get the other x. So I get 0. So one of my answers is 0, 0. And on this one, I solve this. So I add the 2 to the other side. So y is equal to 2. Put the 2 in here. And I get negative 2 times 2 is equal to my other x. So negative 4 is my other x. And writing that as an ordered pair, I get negative 4, 2. So those are my 2 answers. This happens to be a parabola and a line, and they cross at these 2 places. Okay. Sometimes when I make things easier, you guys, can't comprehend when it gets easier. So I like to give you a real easy problem, see if you can figure it out. Okay. So see if you can complete this. All right. So you gave it a shot, right? Well, here's why. Here's my substitutes already done. Okay, so I'm going to put the 6 in for y here. So 6 squared is 36. Subtract the 36. I want equal to 0. Or you can subtract the 9 and get a 25. Either way it works. Take the square root of both sides and make sure that you remember that when you take the square root of a square, you get plus or minus 5. All right, now you say, well, but there's no place to put this back in. I don't know what y is. Well, you don't know what y is because y is given. Y is 6. It's already been done. Okay, so your answer is going to be negative 5, 6, 5, 6. All right, so just to show you what this looks like, here is my hyperbola and my line. My line y is equal to 6 looks like this. My hyperbola looks like that, and then these are the 2 places, negative 5, 6, and positive 5, 6 are the 2 points on my graph where they intersect. All right, so we're going to substitute for the y. So this is my substitute here. Put that in here. Now, I put that in parentheses. This is one of those cases where you have to have the parentheses to make this work out. So this is going to be x squared minus x squared minus 25, which makes this a positive 25. So now I have 25 is equal to 7. You go, wait a minute, I did something wrong. No, you didn't do anything wrong. This is no solution. I have here a hyperbola, two hyperbolas that never cross. Okay, they could either be inside each other, or one could be going up, one could be going down, and then the other one is going from side to side, so they never cross. So there's no solution for this. All right, so let's go back to this problem. On a farm with only cows and chickens, you're told that there are 27 heads and 66 legs. How many of each animal are there? Did you figure a way to make this work? A lot of you will do this with a guess and check, but let's just use what we just did, okay? Now, I'm going to set this up algebraically. First problem, and the major problem that everybody asks me, is I don't know what to write. And once they start it, they get lost in their own work because they don't know what variables they're using. Now, I'm going to use M and C for cows and chickens, but you got to write down what they stand for. Not that M stands for cows. M stands for what about the cows? How many legs they have, how good they taste, how cute they are. What is M? M is how many cows. And since cows and chickens start with a C, I use M for moves and C's for clucks. Okay? So basically I'm using the letters for the sound that they make because the animals will both start with a C. So the number of cows and the number of chickens are very important things to write down when you're writing the variables. Okay, now I'm going to write, since I have two things I don't know, I need two equations. This is what the system of equations does for us. So I'm going to keep track of the heads, right? That's what we're given, and the legs. So I have 27 heads, and each moo, right? Each moo has one head, and each cluck has one head. Altogether I have 27 heads. Counting legs, each moo has 4 legs, and each chicken has 2 legs. That comes out to 66. Now I have two equations, a system of equations with two variables. Now I can go ahead and solve it just like the other ones. First thing I do is find a substitute. You can either solve this for M or solve this for C. I'm going to solve it for M, subtract the C to the other side. Here's my substitute. 27 minus C is my substitute. Put that in my equation. Notice I put that in parentheses again because I need to distribute that 4. Okay, distributing that 4, I get 108 minus 4C plus 2C is equal to 66. Combine my like terms, subtract the 108 from the other side, divide by -2, I get 21 chickens. And how do I know how many cows? I'm going to put the 21 back in my substitute here, and I get 6 cows. So always write your answer in context. This is really important for people doing math and not just playing around with math. Okay, if you're serious about math, as most of you are because you're taking pre-calculus, write the answer in context. You have 6 cows and 21 chickens. All right, make sure you do the Google form, and I will see you tomorrow. Okay, the Google form. There are a couple of questions on here that requires you to see the problem. So here you go. What is the maximum number of solutions possible with a conic and a line? Number 2, what is the maximum number of solutions possible with 2 lines? Okay. Number 3, solve the system. Number 4, solve this system. Number 5, solve this system. And number 6, a farm has only cows and chickens. You count 31 heads and 116 legs. How many cows are there? Okay, all right.